One day, the universe will fade away. No stars, no heat, no movement, just a cold silence that will envelop everything. This audiobook takes you on a journey to explore the quantum winter, the final destination where useful energy disappears and the cosmos remains frozen forever. How would the universe reach this state? And what would it mean for the last spark of matter and life? A journey to the end of time where the heat of everything we know slowly extinguishes into darkness. Quantum winter refers to a theoretical state of the universe where the laws of quantum physics dominate. But what is quantum physics? For many, it may seem like a complex and confusing territory. However, this branch of science is essential for understanding how things work at a fundamental level. Rather than being a field detached from everyday life, quantum mechanics is the foundation upon which many of the modern technologies we use are built. From mobile phones to lasers. Isn't it amazing to think that, at the heart of these devices, the strange quantum reality is at work? Let's think of the universe as a huge puzzle. Each piece represents a part of reality that we are trying to understand. Quantum mechanics provides us with the necessary tools to fit those pieces together, revealing patterns and connections that would otherwise remain hidden. But what is the role of quantum winter in this puzzle? It might be the key that helps us unravel the secrets of the cosmos. Imagine that the universe has a story to tell, a narrative that dates back to its beginnings. Did you know that the universe began with a monumental explosion called the Big Bang? In that instant, all the matter and energy we know emerged from an infinitely small point. How is it possible that from a single point has emerged all the vastness we see today? The first particles that formed at that moment are the basis of everything that exists. However, to understand its evolution, we must delve into the quantum world. Quantum mechanics challenges our intuitions. In this quantum universe, particles can be in multiple places at once and can communicate instantaneously with each other, regardless of the distance that separates them. Can you imagine being in two places at the same time? Although this seems straight out of a science fiction movie, it is a real phenomenon in the quantum world. This kind of behavior leads us to think that perhaps reality is not as straightforward as it seems. Now let's talk about quantum vacuum, a concept that may seem contradictory. How can there be something in the vacuum? In the quantum world, even empty space is filled with energy and possibilities. In this vacuum, particles can momentarily arise, like bubbles appearing and disappearing in a sea of energy. These fluctuations are the seeds of particle creation and, therefore, of everything we know. The theory of cosmic inflation offers us an additional perspective. What if I told you that the universe expanded faster than the speed of light immediately after the Big Bang? This sudden expansion, like the stretching of a balloon, helped shape the structure of the cosmos. How does this affect what we see today in the night sky? The galaxies and stars we observe are just a part of a vast and complex web that originated in that primordial moment. When talking about cosmic structures, it's impossible not to mention dark matter. Did you know that most of the universe is made up of matter we cannot see? This dark matter does not emit light or energy, but its influence is critical. It acts as an invisible skeleton that holds galaxies in place. Without it, the universe as we know it would not exist. Have you ever wondered what mysteries this matter hides? And then there is dark energy, another cosmic enigma. What is accelerating the expansion of the universe? Dark energy could be the answer. This mysterious force makes up about 70% of the universe, and its nature remains one of the greatest challenges for scientists. How can something so omnipresent remain so elusive? As we navigate through these concepts, we cannot forget about entropy. This principle tells us that disorder tends to increase over time. What implications does this have for the future of the universe? Entropy could be the reason why the universe tends toward a final state of equilibrium known as the Big Freeze, where everything cools and disperses. Reflecting on this leads us to question the ultimate fate of everything we know. On this path of discoveries, the information paradox raises even deeper questions. What happens to information when something falls into a black hole? The idea that information is conserved despite the most extreme circumstances challenges our understanding of reality. This is a dilemma that continues to intrigue physicists and philosophers alike. The notion of parallel universes also comes into play. What if there were alternative realities, where every decision we make creates a new universe? This is the proposal of the multiverse theory, which suggests that our reality is just one of many. How would our perception of the world change if we accepted that infinite versions of ourselves exist? Finally, string theory and quantum entanglement take us even further. Is it possible that all the forces of nature are interconnected in a single cosmic fabric? This idea invites us to imagine a universe where everything is linked, where particles can communicate with each other in ways we do not yet fully understand. Thus, as we conclude this introduction to quantum winter, we face a series of questions that invite us to reflect on our place in the vast universe. Science not only seeks answers but also awakens our curiosity and drives us to keep exploring. What new truths await us on this journey? The adventure is just beginning. How did it all begin? That is one of the most intriguing questions we ask about our universe. Imagine the scene. Everything we know, everything that exists, started as an incredibly small and dense point. In an instant, this point exploded in an event we know as the Big Bang. But what does that really mean? How is it possible that from an explosion arose the first subatomic particles that would form the basis of everything we see today? Let's think of the Big Bang as the moment we ignite a spark in the darkness. In that instant, everything we know expanded explosively, giving rise to vast space and time. But what happened in those early moments? The first particles, like electrons and protons, began to form almost instantly. These particles are the basic building blocks of matter. Without them, there would be no atoms, and without atoms, there would be none of what we see around us. Now, it's fascinating to think that at first the universe was so hot that particles could not come together to form atoms. It was like a bubbling ocean of pure energy. As the universe expanded, it began to cool. Can you imagine being in a place where everything is energy? Over time, conditions became favorable and electrons joined with protons to form hydrogen atoms, the simplest and most abundant element in the universe. But where do stars and galaxies come into play? With hydrogen at hand, the universe began its journey toward the formation of more complex structures. Gravity, that mysterious force that keeps our feet on the ground, started to attract hydrogen atoms. Over time, these clouds of gas began to collapse under their own gravity, giving rise to the first stars. Imagine a huge cauldron of cosmic soup where the ingredients mix and gradually turn into something delicious. These first stars were crucial. Inside them, through nuclear fusion processes, they began to create heavier elements. It is here that helium, carbon, and other essential elements are forged, as if in a cosmic kitchen. But what happens when these stars exhaust their fuel? It's an impressive cycle. They explode in supernovae, scattering those heavy elements throughout space. Thus, life as we know it may have its roots in the guts of these dying stars. When we talk about the origin of the universe, we cannot overlook the idea of expansion. The universe not only began to exist, but it also began to grow. Every corner of space is moving away from us. It's as if every point on a balloon separates as we inflate it. What does this mean for our place in the cosmos? It means we are in a constantly changing universe full of possibilities and mysteries to discover. As the universe continued to expand and cool, the first galaxies formed. These massive structures are like cosmic cities with billions of stars, planets, and other celestial bodies. The formation of galaxies is a fascinating and complex process, where gravity plays a fundamental role. But how do we know all this? Thanks to observation and science, we have been able to reconstruct the history of our universe, although many questions remain unanswered. Some of these questions lead us to reflect on our place in the universe. If everything began with the Big Bang and we are made of the same elements that formed in the stars, what does this tell us about our connection to the cosmos? We are the result of billions of years of cosmic evolution. What we see in the sky is not just a visual spectacle, but a reminder of our shared history with the universe. It's amazing to think that the matter that makes up our body was once part of a distant star. In a sense, we are all stardust. This idea invites us to look up and ask ourselves what else is out there. The universe is vast and full of mysteries, and while we have made great strides in our understanding, the truth is that we are just beginning to scratch the surface. The exploration of our origin is a journey that never seems to end. Each discovery leads us to new questions, new curiosities. What else is left to discover about the cosmos? What secrets still remain hidden in the vastness of space? The answers to these questions call us to keep exploring, to keep learning. So as we reflect on the Big Bang and the birth of the first subatomic particles, let's remember that we are on a shared journey, a journey that began billions of years ago and continues today. Understanding the universe is not just a scientific achievement, but an invitation to marvel at the immensity of what surrounds us. Every star in the sky tells a story, and each story brings us a little closer to understanding our place in the vast theatre of the cosmos. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Quantum mechanics is a fascinating labyrinth of ideas that challenge our intuition. What if I told you that subatomic particles can be in multiple places at the same time? This is not just a science fiction madness, but one of the cornerstones of quantum mechanics. This field of physics invites us to rethink our understanding of the universe and the very nature of reality. Let's consider how everyday objects behave. If you throw a ball, you know exactly where it will land, but in the quantum world, particles are more like moving shadows, changing location and state in unpredictable ways. This strange duality allows scientists to explore behaviors that defy our logic. Particles can appear and disappear, and their existence may depend on whether they are being observed or not, as if they were actors on a stage that only come to life when the audience is present. Now, how does all this relate to light? Light is not just a wave traveling through space. It also behaves as if it is made up of tiny particles called photons. This phenomenon is known as wave-particle duality. If you've ever wondered how light can travel through a vacuum and still cast a shadow, you are touching the core of a quantum mystery. Light, like subatomic particles, does not behave in a fixed and predictable manner. And this is just the beginning. Imagine you are in a room full of ping-pong balls. If you throw a ball, the trajectory it follows is clear and direct. However, in quantum mechanics, if you throw a particle, the trajectory is not so simple. It can go in multiple directions at once, as if it is following a path of possibilities rather than a single defined path. This idea may seem puzzling, but it is fundamental to understanding how the universe works at a subatomic level. Quantum mechanics also introduces the uncertainty principle, which tells us that we cannot precisely know both the position and the velocity of a particle simultaneously. Why is this so important? Because it challenges our idea that we can measure and know everything in the universe. In the quantum world, there are limits to our knowledge. We could say that the universe has its secrets, and sometimes those secrets are unreachable. What about superposition? This concept suggests that a particle can be in multiple states at the same time. Imagine a coin spinning in the air. While it is in motion, it is not just heads or tails, but both at the same time. That is the essence of superposition. The moment the coin lands, a single outcome is revealed. But before that, it has the potential to be both things. This phenomenon becomes a fundamental part of quantum mechanics, creating a world full of possibilities. We could think about the double-slit experiment, in which a particle can pass through two slits at the same time and create an interference pattern as if it were waves in a pond. How is it possible for a single particle to act as if it were two? This experiment illustrates the strange nature of quantum mechanics and how it challenges our understanding of space and time. Quantum mechanics is not limited to individual particles. It also deals with larger and more complex systems. For example, the way electrons behave around an atomic nucleus is a quantum phenomenon. Electrons do not orbit the nucleus like planets around the sun. Instead, they exist in probability clouds where they are more likely to be found in certain areas than in others. This model helps us understand how atoms are formed and therefore matter itself. But how does all this relate to the technology we use every day? Quantum mechanics has enabled incredible advancements, from the design of microchips to the creation of lasers. Without it, many of the modern devices we consider common would not exist. So every time you send a text message or make a video call, you are using quantum principles without realizing it. Quantum mechanics also opens the door to even more exotic concepts such as quantum entanglement. This phenomenon occurs when two particles become interdependent in such a way that the state of one instantaneously affects the state of the other, even if they are separated by large distances. This raises intriguing questions about the nature of information and communication in the universe. Looking to the future, quantum mechanics is not just an academic field of study. It is also the foundation of quantum computing, a technology that promises to revolutionize our ability to process information. Instead of using bits that are zeros or ones, quantum computers use qubits that can be both at the same time, allowing for much faster and more complex calculations. As we explore the quantum world, we realize that we are only at the beginning of an incredible journey. Quantum mechanics not only transforms our understanding of the universe, but also challenges us to question what we think we know about reality. Every discovery in this field opens new questions, and each answer seems to lead us to a new layer of mystery. Are we prepared to face the unknown, or do we prefer to cling to what we believe is true? Quantum mechanics not only teaches us about the universe, it also invites us to reflect on ourselves and our place in it. In the fascinating world of quantum mechanics, the concept of vacuum is anything but empty. We often think of vacuum as a space devoid of matter, a place where there is nothing. But in the quantum reality, the vacuum is a hotbed of activity. What does this mean? Imagine a calm sea where the surface appears tranquil, but in its depths, currents and hidden creatures are always in motion. This is quantum vacuum. A space where, at first glance, there is nothing, but which is actually full of potential and energy. What is in the quantum vacuum? For physicists, the vacuum is not simply the absence of particles. It is a state where particles can be created and annihilated constantly. This phenomenon is due to the very nature of quantum mechanics, where particles can appear and disappear in the blink of an eye. Think of it as a magic trick where the cards that seem to be absent from the table suddenly appear. In the quantum vacuum, particles manifest and vanish in a constant flicker, challenging our traditional understanding of what it means to exist. One of the most intriguing questions that arises is, how can something arise from nothing? Apparently, in the quantum vacuum, this is not only possible but the norm. In this context, virtual particles, which cannot be directly observed, emerge and disappear but leave their mark on the universe. These particles are like shadows of what could be, and their ephemeral existence can influence phenomena we observe, such as the force of gravity or the radiation emanating from black holes. The quantum vacuum is also essential for understanding why the universe has more matter than antimatter. When the universe was created, pairs of particles and antiparticles were generated. However, for reasons we still do not fully understand, a slight imbalance occurred, allowing an excess of matter to remain. So in this sense, the vacuum is not just a space, but a stage where the most fundamental stories of our universe unfold. Have you ever wondered what implications all this has for particle creation? In a broader sense, the quantum vacuum is the primordial soup in which subatomic particles form. When certain conditions are met, such as the right temperature or energy, these particles can emerge from the vacuum. Thus, the vacuum becomes a fertile ground for creation, where the right conditions can give rise to new worlds. Just as life can sprout from barren land when it rains, physicists have found ways to study this quantum vacuum, and one of the most important tools they have developed is quantum field theory. This theory helps us understand how particles interact with each other and how they behave in the vacuum. It is like a map that guides us through a landscape that would otherwise be completely unknown. But what happens when this vacuum is disturbed? The answer is that fluctuations are created that can have a profound impact on the structure of the universe. The idea that the vacuum is not really empty may seem puzzling, but it is precisely this paradox that makes quantum mechanics so fascinating. Imagine you are in a silent room and suddenly hear a whisper. Where does it come from? That is the essence of what happens in the quantum vacuum. Fluctuations are like whispers in the stillness, bringing life and movement to what seem to be calm. The implications of understanding the quantum vacuum are enormous. For example, this vacuum is what allows gravity to act in the universe. Without this subtle fabric of interactions, stars and galaxies could not form as they do. Thus, the vacuum becomes the stage where cosmic plots unfold, and each star, each planet, is the result of an elaborate game of creation and annihilation that occurs in this seemingly empty environment. Now let's think about how the quantum vacuum relates to the energy of the universe. This vacuum is not only a space of creation, but also has energy. This energy oscillates and manifests in different forms. In quantum theory, it is said that the vacuum has a zero energy value. But this does not mean it is inactive. Rather, it is a constant source of energy that can influence everything from galaxy formation to the expansion of the universe. Finally, it is fascinating to consider how all this connects to our own existence. If the quantum vacuum is the fabric from which particles arise and therefore the matter of which we are made, then we can say that we are all, in a sense, children of the vacuum. Each of us is a manifestation of the potential that resides in that seemingly empty space, reminding us that, at the essence of reality, there is always more than meets the eye. So when you think about the quantum vacuum, remember that it is not about absence, but about vibrant potential. At the heart of quantum mechanics, the vacuum is much more than a simple nothing. It is a place where realities are forged, where creation and annihilation coexist in an eternal dance, and where, perhaps, lies the key to understanding the very nature of the universe. Have you ever heard of cosmic inflation? This concept is as fascinating as it is crucial for understanding how our universe was formed. Imagine that the universe we know, filled with galaxies, stars, and planets, was once an incredibly small point, smaller than a grain of sand. Everything that exists today, all matter and energy, was concentrated in that tiny space. But then suddenly something extraordinary happened. Cosmic inflation is like a burst of growth that occurred right after the Big Bang. In an instant, the universe expanded exponentially, much faster than the speed of light. Can you imagine? In less than a second, the universe went from being a point to encompassing an immense expanse. This period of expansion was so fast that, if we compared it to inflating a balloon, it would be like inflating one the size of a planet in the blink of an eye. But why is this expansion important? Well, cosmic inflation helps explain why the universe is so uniform in its distribution of matter. Without it, we might expect to see a universe filled with irregularities, with dense areas and others empty. However, what we observe is a cosmic microwave background that is almost perfectly uniform. Inflation provides a mechanism for these irregularities to smooth out, creating a more homogeneous cosmos. Every time we look at the night sky, we face an intriguing question: why is there more matter than antimatter in our universe? During the inflationary period, conditions were so extreme that small quantum fluctuations were generated. These fluctuations are like bubbles in a fizzy drink. Some bubbles grow larger than others. As the universe expanded, some of these small variations in density became the seeds of the galaxies and structures we see today. Imagine you are in a park filled with colorful balloons. If you inflate a few balloons more than others, those larger balloons will take up more space. Similarly, the fluctuations in the density of the universe expanded, forming galaxies. But what role does energy play in all this? Cosmic inflation is also related to dark energy, which is the mysterious force driving the accelerated expansion of the universe today. Now, you might be wondering, what happens after inflation? Once the universe stabilized after this frantic growth period, it began to cool down. This cooling allowed subatomic particles to start joining together and form the atoms that would eventually give rise to stars and galaxies. It's like when you cook pasta. At first, the water bubbles and boils, but when you take the pot off the heat, the water calms down and the noodles start to take shape. Scientists have tried to test the theory of inflation through various observations. For example, they have studied gravitational waves, which are ripples in space-time caused by massive events such as the merging of black holes. By observing these waves, researchers hope to find evidence that supports cosmic inflation. If this proof were found, it would be a significant step toward understanding the early moments of the universe. However, inflation also raises complex questions. For instance, if the universe expanded so rapidly, could there be other universes that also expanded in different directions? This idea leads us to the notion of multiverses, where each universe could have its own physical laws and constants. Imagine a vast ocean of bubbles, each representing a different universe, some with life, others without it. This vision prompts us to rethink our position in the cosmos. Moreover, cosmic inflation not only explains the past of the universe, but also influences its future. If dark energy continues to drive the expansion, we could face a destiny where the universe keeps expanding indefinitely. This leads us to a profound question: how will this affect life in the future? In an expanding universe, galaxies will drift further apart from each other, eventually making them invisible. Reflecting on cosmic inflation, it is clear that it is not just an event of the past, but a phenomenon that shapes our understanding of the universe as a whole. It invites us to question and explore beyond what we see, to dive into the mysteries of the cosmos. Every discovery we make about inflation and its impact brings us closer to answering questions that have intrigued humanity for centuries. So the next time you look at the starry sky, think of that fleeting moment of cosmic inflation. In that instant, everything we know began to take shape, from a tiny space to a vast universe full of wonders. The story of our existence is intertwined with these phenomena, reminding us that, although we are small compared to the immensity of the cosmos, our curiosity and desire to understand make us part of something much greater. Dark matter is one of the greatest mysteries of the universe. What is it, and why is it so crucial for understanding how galaxies and cosmic structures form? To begin with, let's think of a large puzzle. Imagine you have all the visible pieces, but you realize that many are missing to complete the picture. That incomplete image represents our universe. Dark matter is precisely what is missing. We don't see it, but we know it is there, influencing everything around us. To illustrate this, consider a party in a hall. The lights are off, and you can only see the people who are close to you. However, you know there are more people in the hall, even if you can't see them. The gravity you feel from those other guests, pushing and pulling on those you can see, is similar to how dark matter interacts with visible matter in the universe. Without it, galaxies would not behave as they do. But how can we know that dark matter exists if we cannot see it? One of the most important clues comes from the galaxies themselves. When astronomers observe how galaxies rotate, they notice something strange. The stars at the edges of a galaxy spin at much higher speeds than they should, given the amount of visible matter present. It's as if they are being pulled by an invisible string. That string is dark matter, acting as an invisible skeleton that holds galaxies in place. Dark matter not only affects individual galaxies, but also the way they are distributed throughout the universe. Imagine you are looking at a spider web. The intersections of the threads represent the galaxies, and the web itself is the dark matter that connects everything. Without that web, galaxies could not cluster as they do, and the universe would look very different. Now, what constitutes this dark matter? Unlike normal matter, which is made up of atoms and particles we know, dark matter seems to be composed of mysterious particles that we have yet to identify. Several theories have been proposed, from weakly interacting massive particles to axions, which are even more elusive particles, but so far none of these particles have been directly detected. A useful analogy is to think of air. Although we cannot see it, we know it is there because we feel its presence when the wind blows or see how it moves the leaves of trees. Similarly, dark matter is like that air, invisible but essential for the behavior of the universe. Without it, galaxies would disperse and the universe as we know it would collapse. Sometimes it is said that dark matter is like a ghost in a room. We know it is there by the effects it causes, but we cannot see or touch it. This elusive nature has led many scientists to wonder, could we one day find direct evidence of its existence? The answer is a fascinating puzzle that lies at the heart of research in physics and astronomy. Although dark matter may seem like an abstract concept, it has very real implications. Without it, we would not have the universe as we know it. Galaxies would not have formed in the same way, and consequently, planets, stars, and life as we know it would not exist. Therefore, its study is not just an academic exercise, it is fundamental to understanding our place in the cosmos. The search for dark matter has led to the creation of cutting-edge experiments and observatories. Imagine large underground detectors deep in the Earth designed to catch the rare interactions of these elusive particles. Every time scientists believe they have found a signal, excitement and anticipation grow, only for reality to often tell them that it is still not the time to unveil this mystery. Dark matter also raises intriguing philosophical questions. If most of the universe is made of something we cannot see or touch, what does that mean for our understanding of reality? Are we really seeing the universe as it is, or just a small part of a much larger picture? These questions lead us to reflect on the limits of our knowledge and the nature of existence itself. As technology advances and our understanding of physics deepens, dark matter will continue to be a field of intense research. Scientists are increasingly convinced that at some point we will unravel this enigma. Perhaps we will discover that dark matter is not only an essential part of the fabric of the universe, but also a bridge to new dimensions of understanding. So the next time you look up at the starry sky, remember that not everything that shines and exists is visible. There is a hidden universe full of mystery and possibility, inviting us to explore it. Dark matter, with its invisible nature and powerful influence, is just the beginning of a cosmic adventure that is yet to be revealed. Dark energy is one of the most intriguing mysteries of the universe. What exactly is it? Imagine you are inflating a balloon. At first, the balloon is small and doesn't seem to have much inside, but as you blow air into it, the balloon expands and expands until it seems like it can't hold any more air. However, there comes a point where even if you stop blowing, the balloon keeps growing. This is somewhat similar to what is happening in our universe. For some time, astronomers have observed that the universe is not only expanding, but that this expansion is accelerating. Why does this happen? The answer seems to be related to dark energy, a mysterious force that acts like a kind of anti-gravity. But how do we know it exists? The key lies in observations of supernovae, those bright stellar explosions that mark the end of some stars' lives. By studying these explosions, scientists noticed that the most distant supernovae were fainter than expected. This suggested they were farther away than we thought, and therefore that the universe was expanding faster than previously calculated. Dark energy accounts for about 73% of the total energy of the universe. It is a difficult concept to grasp since we cannot see or touch it. It is often described as a kind of void that pushes galaxies away from each other. But is it really a void? In reality, we don't know for sure. Dark energy could be a property of space itself, something that is present everywhere and affects how the universe behaves on a large scale. To better understand dark energy, let's think of space as an elastic fabric. If you place marbles on that fabric and stretch it, the marbles move away from each other. Similarly, as space expands, galaxies separate. But here's where it gets complicated. Instead of just stretching, the fabric is expanding at an accelerated rate. That acceleration is what we call dark energy. What if I told you that dark energy could have implications beyond physics? Some scientists suggest it could influence how we understand gravity. If dark energy is present throughout space, it could change our view of the forces acting in the universe. This leads us to wonder, could dark energy be a manifestation of new physics yet to be discovered? The theories about dark energy are varied. Some scientists believe it could be a cosmological constant, a term proposed by Albert Einstein in his famous equation of relativity. This constant would represent a negative pressure that drives the expansion of the universe. However, others suggest that dark energy could be a dynamic phenomenon that changes over time. The truth is that so far, we do not have definitive answers. The implications of dark energy are vast. If it continues to exist as we understand it, it could lead to a future where the universe expands indefinitely, creating a scenario known as the Big Freeze, where galaxies move so far apart that they eventually become invisible. Imagine a universe where stars go out and cold takes over existence. A place that might seem empty and lonely. On the other hand, if dark energy behaves differently, we could face a big crunch where the expansion stops and the universe begins to contract, collapsing everything into a point of singularity. This idea may sound terrifying, but it is also fascinating. An eternal cycle of expansion and contraction. Dark energy also raises philosophical questions. If dark energy is what is driving the expansion of the universe, what does this mean for our understanding of reality? Are we alone in this vast cosmos, or are there invisible forces shaping our destiny? And amidst all this, dark energy reminds us of how little we truly know about the universe. Each discovery opens new questions, and each answer seems to lead us to more mysteries. This is the beauty of science. It is an endless journey into the unknown. So, as we look at the stars and reflect on our place in the universe, let's remember that there are invisible forces shaping our reality. Dark energy is just one of the many pieces of a cosmic puzzle that we are still trying to solve. As we move forward in our quest for knowledge, dark energy will continue to be an intriguing topic that drives us to explore beyond the known, always seeking answers to the deeper questions about our universe and our place in it. What is entropy, and why is it crucial for understanding the universe? To answer this question, we first need to think about a concept we all know: disorder. Imagine your room after a week without cleaning. Toys are scattered, clothes are out of place, and books are piled up haphazardly. That feeling of disorder is a small representation of what scientists call entropy. In the universe, entropy refers to the degree of disorder or randomness in a system. But why should we care about the disorder of the universe? The answer lies in the fact that entropy plays a fundamental role in the evolution of the cosmos. As the universe moves forward in time, entropy tends to increase. This means that in general, things tend to become more disordered and less organized. This principle is known as the second law of thermodynamics. In simple terms, disorder always wins. So what does this imply for our future? When we observe the universe, we can notice that everything from stars to galaxies is in constant change. But what will happen when we reach the point where everything is so disordered that no more organized structures remain? This is where we enter the concept of the Big Freeze, a scenario in which the universe progressively cools as it expands. In this scenario, stars will eventually extinguish, and galaxies will separate so much that the cosmos will become a dark and lonely place. However, not all theories about the future of the universe focus solely on cooling. Some consider the possibility of a big crunch. This scenario suggests that instead of continuing to expand indefinitely, the universe could eventually stop and begin to contract. In this process, all matter and energy would concentrate again in a single point, creating an extremely dense and hot universe. But what does this mean for entropy? This is where entropy becomes even more intriguing. If the universe contracts in a big crunch, we might think that disorder would decrease as everything would gather in one place. However, the reality is that even in a contracting universe, entropy does not stop. During the contraction phase, interactions between particles become increasingly complex, ultimately leading to an increase in entropy. So, whether the universe expands or contracts, entropy is always at play. But is it possible that entropy has a deeper purpose in the universe? Some scientists suggest that the increase in entropy could be related to the evolution and complexity of life. In other words, disorder could be a necessary precursor for more advanced forms of life to emerge. As the universe evolves, complex structures such as stars and planets appear amidst this disorder. Could it be that entropy is, in a way, the spark that ignites the creativity of the cosmos? And if entropy is at the center of everything, what about information? Entropy and information are intimately related in the quantum world. One way to understand this is to think of a puzzle. When all the pieces are jumbled, there is high entropy and little useful information. But as you start to put the puzzle together, entropy decreases and information becomes more accessible. In the context of the universe, this raises fascinating questions. Is information the antidote to the increase in entropy? As we can see, entropy is not just a physical concept, it also has profound philosophical implications. It invites us to reflect on the meaning of life and our place in the vast universe. If disorder is destined to increase, what is the relevance of our actions? Are we in some way contributing to chaos, or, on the contrary, creating order amidst disorder? In this sense, entropy could be seen as a metaphor for life itself. We often face challenges and moments of chaos, but there are also opportunities to create order and meaning. Perhaps our struggle to understand the universe and find our place in it is a reflection of this struggle against entropy. The pursuit of knowledge and the creation of meaningful connections may be our way of dealing with the inherent disorder of existence. In conclusion, entropy is a concept that offers us a fascinating window into the nature of the universe. From the increase of disorder to its relationship with information, entropy challenges us to rethink how we view the cosmos and our role in it. As we continue to explore the mysteries of the universe, we may discover that despite the inevitability of chaos, there will always be space for creativity, life, and connection. What does the future hold for us in this vast sea of disorder? Only time will tell. The information paradox is one of those concepts that, although it seems taken from a science fiction novel, has profound implications for our understanding of the universe. What if I told you that information is so fundamental that it could be the key to understanding the very nature of reality? To delve into this intriguing territory, we must first consider what we understand by information in the context of quantum physics. Information, in simple terms, is any data that we can store, transmit, or process. In the quantum world, information behaves in surprising ways. For example, the states of particles can be so unstable and changing that it sometimes seems that the information about them is lost. But does it really get lost? This question is at the heart of the paradox. The idea that information can disappear challenges many of our notions of how the universe works. Imagine you are in a huge library with millions of books. Each book represents a set of information. Now, suppose a fire consumes some of those books. Is the information contained in them lost? It would seem so, but quantum physicists tell us that somehow that information still exists, even if we cannot access it. This is a concept that has generated great debate in the scientific community. One of the most influential figures in this discussion is physicist Stephen Hawking. In the 1970s, Hawking proposed that black holes could absorb information, taking it to a point from which it could never return. However, this concept generated significant controversy, as it implied that information could completely disappear from the universe. This goes against one of the fundamental laws of physics, the conservation of information. So how do we reconcile this apparent contradiction? Some scientists suggest that information is not lost, but transformed. Imagine the library again. Instead of some books burning, think of it as if they were rewritten in a different language. The information is still there, but in a form that we cannot easily understand. This leads us to think that information may be encoded in the radiation emitted by a black hole known as Hawking radiation. Now let's consider quantum entanglement. This fascinating phenomenon shows us that two particles can be connected in such a way that what happens to one instantly affects the other, regardless of the distance separating them. This entanglement raises intriguing questions about how information is transmitted and whether it can be teleported in some way. Could it be that information not only persists but also shares in ways we do not yet fully understand? The information paradox also has implications for quantum computing. In this new paradigm of data processing, the way we handle information can be radically different from what we know. Quantum computers use qubits, which can represent multiple states at once, allowing for information to be processed in a much more efficient way. This suggests that by better understanding how information works at the quantum level, we could unlock unimaginable capabilities in the future. But what does this mean for us? The idea that information is never lost could influence our understanding of reality and consciousness. If the information about each of us is encoded in the fabric of the universe, could it be that our experiences and memories are also intertwined in a broader network of information? This idea leads us to question our own existence and the role we play in the vast cosmos. As we continue to explore the information paradox, another intriguing question arises. What if information could be the key to understanding the nature of consciousness itself? Some scientists and philosophers have speculated that consciousness could be an emergent phenomenon, resulting from large-scale information processing. This leads us to think about how our minds are connected to the universe and whether there is a way to access that information that seems to have been lost. The information paradox also invites us to reflect on the nature of time. If information can exist outside our conventional understanding of time and space, we might be facing the possibility that the past, present, and future are interconnected in ways we do not yet comprehend. This notion challenges our linear perception of time and encourages us to explore the idea that information could be a bridge between different dimensions of reality. Ultimately, the information paradox is not just a scientific dilemma, it is a mystery that touches the deepest fibers of our existence. As we advance in our understanding of quantum mechanics and the universe, it is essential to approach these questions with curiosity and openness. The quest for answers about information, its conservation, and its role in the structure of the cosmos will lead us to new frontiers of knowledge. At the end of the day, the information paradox reminds us that the universe is a place full of surprises and mysteries. Each discovery brings us a little closer to understanding not only how the cosmos works, but also our own existence within it. And while many questions remain unanswered, the pursuit of knowledge is undoubtedly a journey worth undertaking. What if I told you that the universe could be just one of many realities? The idea of parallel universes or multiverses has captured the imagination of scientists and philosophers alike. In this fascinating exploration, we will delve into how quantum mechanics suggests that other universes might exist, each with its own laws and realities. Imagine for a moment that every decision you make, every little event in your life, creates a fork in the path of time. Every choice you make could lead to a different universe where things turn out differently. What if in another universe you chose a different coffee this morning and that triggered an unexpected turn in your life? This idea, initially a bit perplexing, lies at the heart of the multiverse theory. Quantum mechanics, the branch of physics that studies the smallest parts of the universe, behaves in ways that challenge our intuition. One of the most intriguing principles is that particles can exist in multiple states at the same time, a phenomenon known as superposition. Can you imagine what it would be like if your life could be in multiple states simultaneously? In the quantum world, the possibilities are endless. Now, how does all this relate to parallel universes? A popular interpretation of quantum mechanics, known as the many worlds interpretation, suggests that every time a quantum event occurs, the universe splits into several versions, creating an infinite branching. Thus, every decision, every event could give rise to a new universe, each living its own unique narrative. The idea of multiverses also raises intriguing questions about the nature of reality itself. If parallel universes exist, what does that mean for us? Does it mean that each of us has a version in another universe living a completely different life? Perhaps in one of those universes, humanity has found a way to travel between realities, exploring infinite possibilities. Wouldn't that be exciting? To put it in perspective, let's think of a book. Imagine that each page of that book represents a different universe. Every choice you make Every event that occurs is like turning to a new page where the story unfolds differently. In this sense, life is a constantly evolving book where each decision opens the door to new narratives. And if that weren't enough, the theory of multiverses also intertwines with other fascinating concepts in physics. For example, some scientists suggest that bubbles of space-time could be constantly creating new universes. In this model, our universe would be just one bubble among many, floating in an infinite sea of realities. What mysteries could be hidden in those other bubbles? However, the idea of parallel universes is not just a theoretical game. Some quantum experiments have begun to provide evidence supporting the existence of these worlds. Although we are still far from fully understanding how all this works, each discovery brings us a little closer to the truth. Who knows what revelations await us in the future? The notion that we might exist in multiple universes also raises profound philosophical questions. If in one universe you make a decision and in another you do not, what does that mean for your identity? Are you a single person or a collection of all those versions of yourself in different realities? This dilemma invites us to reflect on the nature of the self and how our choices define our existence. Moreover, the concept of multiverses invites us to consider the possibility that other forms of life, with their own stories and realities, may be coexisting in those parallel universes. What kinds of beings might inhabit those other worlds? Will they have their own struggles and achievements similar to ours, or will they be completely different? The journey through the idea of parallel universes is a reminder of how little we truly know about the cosmos. It challenges us to remain curious and open to new ideas. In a universe where anything is possible, imagination becomes our greatest tool for exploring the unknown. As we reflect on this incredible notion, it becomes evident that science and philosophy are intertwined in surprising ways. Each discovery in quantum mechanics not only offers us a deeper insight into the universe, but also invites us to question our own existence and the place we occupy in the vast cosmos. Finally, although the theory of multiverses may seem like something out of a science fiction novel, the reality is that every day we get closer to unraveling the mysteries of the universe. Each new finding in quantum physics and cosmology offers us a new perspective on who we are and what we could be. In this endless journey toward understanding, the idea of parallel universes reminds us that at our core, we are part of something much larger and more astonishing than ourselves. String theory is like a vast ocean of possibilities where each wave represents a new way of understanding the universe. Have you ever wondered if the reality we know is just a small part of something much larger? String theory suggests that, instead of being just individual particles, everything in the universe is made up of tiny vibrating strings. But what are these strings and how can they change our view of the cosmos? Visualize a guitar. When you pluck a string, it vibrates and produces a specific musical note. Similarly, the strings in string theory vibrate at different frequencies. Each frequency of vibration translates into a different subatomic particle. In other words, electrons, quarks, and other fundamental particles are like the notes of a cosmic symphony, composed of these strings vibrating in a multidimensional space. The idea that everything is made of strings may sound strange, but what's fascinating is that this theory attempts to unify the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. Wouldn't it be amazing if we could understand the entire workings of the universe under a single theoretical framework? String theory seeks precisely that, to unite all the pieces of the puzzle into a single coherent picture. Now, how does this theory relate to concepts that seem to be in conflict, like gravity and quantum mechanics? For a long time, these two fields of physics have existed in separate worlds, each with its own rules. String theory presents itself as a bridge, a way to reconcile the quantum nature of subatomic particles with the structure of space-time that describes gravity. Imagine we are trying to fit two pieces of a puzzle that don't match. String theory could be the key to finally making them fit. As we delve deeper into this idea, we encounter an intriguing concept: The existence of additional dimensions. In our everyday experience, we live in a world of 3 spatial dimensions and 1 temporal dimension, but string theory suggests that there are more hidden dimensions, perhaps up to 10 or 11. What if these additional dimensions are like invisible hallways connecting different realities? The existence of these dimensions could explain phenomena that current physics cannot, such as gravity at a quantum level. This leads us to a fascinating dilemma. If strings and hidden dimensions are real, why don't we perceive them in our daily lives? The answer might be that these additional dimensions are so small that we simply do not notice them. Imagine you are walking down a road and there is a tiny sphere rolling at the edge. Although it is present, it is so small that it becomes almost invisible. In the same way, hidden dimensions may be all around us, but our sensory capabilities cannot detect them. String theory not only attempts to unify the fundamental forces, but also suggests that the universe may be a much richer and more diverse place than we think. Some scientists even speculate that we might be living in a multiverse where different universes coexist, each with its own physical laws. What does this mean for our understanding of life and reality? Perhaps there are other universes where the rules are completely different, where gravity acts differently, or where particles have unique properties that we could not imagine. However, string theory faces criticism and challenges. Some physicists argue that it is difficult to test experimentally. But isn't this the nature of science? Often the most revolutionary theories emerge before we have the technology to verify them. Just like ancient theories about electricity or magnetism, string theory could be an early step toward a deeper understanding of the universe. As we explore further, we encounter the fascinating world of wormholes. These structures could represent shortcuts through space-time, connecting different points in the universe. If string theory is correct, perhaps these tunnels could exist in those additional dimensions that we have yet to discover. Imagine being able to travel across the universe in the blink of an eye, crossing vast distances in seconds. This idea is not only exciting but also challenges our understanding of what is possible. Ultimately, string theory invites us to question what we think we know about reality. It pushes us to think beyond our limitations and consider that the universe is a place full of mysteries waiting to be uncovered. The beauty of science lies in its ability to adapt and evolve as we gain new knowledge. String theory is just one of many tools in our arsenal that helps us unravel the secrets of the cosmos. So, as we reflect on string theory, we may ask ourselves, what other secrets does the universe hold for us? What unexpected discoveries are just around the corner? Each new theory, each new piece of evidence brings us one step closer to unveiling the vast and complex mosaic that is our universe. Perhaps, on this path of discovery, we will find not only answers to our deepest questions, but also a more intimate connection with the cosmos in which we live. Have you ever felt that there is more than what we perceive at first glance? In the fascinating world of quantum mechanics, this feeling becomes a tangible reality. One of the most intriguing concepts in this branch of physics is quantum entanglement. But what does this really mean, and why is it so important for our understanding of the universe? Imagine you have 2 cards from a deck and you place them in 2 distant locations. If you decide to flip one of them, you instantly know what is on the other, no matter how far apart they are. This is the basic principle of quantum entanglement. 2 particles can be connected in such a way that the state of one affects the state of the other, without any physical communication between them. It's as if they have an invisible bond that blurs the lines of distance. The question that arises is, how can this be possible? According to quantum mechanics, particles can exist in multiple states at once. When a measurement is made, these particles decide which state to remain in. But the fascinating part is that the state of an entangled particle is determined instantaneously, regardless of the distance separating them. This has led many to wonder if there is something beyond our current understanding of reality. Quantum entanglement challenges our notion of separation. Could it be that, at a fundamental level, everything in the universe is interconnected? This idea has led to deep reflections on the nature of reality and human perception. Are we truly alone in our experiences, or is there a common fabric that binds our existences? The implications of entanglement go beyond theory. In the world of technology, this phenomenon is being explored to develop quantum communication networks. Imagine an instant messaging system that is completely secure, where information is protected from any attempts at espionage. This is what quantum computing promises, using entanglement as a key component. As we advance in the study of this phenomenon, even more intriguing questions arise. Could we, in theory, use entanglement to send information faster than light? Although modern physics sets limits, scientists' imaginations remain open to possibilities that challenge our traditional ideas about time and space. On the other hand, entanglement also raises philosophical dilemmas. If two particles can be connected so deeply, what does this mean for our understanding of individuality and freedom? Are we all in some way entangled in a vast web of existence? These questions touch not only the realm of science, but also delve into philosophy and metaphysics. Some researchers have proposed that entanglement could have implications for consciousness. Is it possible that our minds are entangled in some way? Although these ideas may seem strange, they invite us to reflect on our own nature and our relationship with the universe. The boundary between science and spirituality becomes blurred when we consider that everything could be interconnected. Quantum entanglement also challenges our notions of time. In the quantum world, time does not flow in the same way we perceive it in our daily lives. This raises the possibility that the past, present, and future are more interconnected than we believe. Could we at some point learn to manipulate this connection in a way that allows us to influence our realities? As we explore these concepts, it is important to remember that quantum entanglement is not just a theoretical phenomenon. Experiments in laboratories have demonstrated its existence and confirmed that, at a subatomic level, reality is much stranger than we could have imagined. This leads us to question not only the nature of the universe, but also our place in it. The beauty of quantum entanglement lies in its ability to inspire. It invites us to look beyond the obvious and explore the connections that unite us. In a world where we often feel disconnected, this idea of entanglement can serve as a reminder that we are all, in some way, intertwined in this vast universe. As science advances, the potential of quantum entanglement could open the doors to new technologies and discoveries. From quantum computing to cryptography, the applications are vast and revolutionary. This phenomenon not only gives us a new way to see the world, but also propels us toward a future full of possibilities. In summary, quantum entanglement is a concept that not only challenges our notions of reality, but also invites us to explore the connections that unite us. It makes us question our own existence and the role we play in the grand scheme of the universe. As we continue to investigate and discover, quantum entanglement could be the key to unraveling the deepest mysteries of nature. Are you daring enough to keep exploring this fascinating labyrinth of connections? Welcome to the fascinating world of quantum computing, an area that has captured the imagination of scientists and enthusiasts alike. What makes this technology so special? To understand it, we first need to think about how the computers we use today work. Conventional devices operate with bits, which are like small switches that can be on or off, thus representing a 1 or a 0. But what if there were a way to process information in a much more efficient manner? This is where qubits come in. Qubits are the basic unit of information in quantum computing, and their magic lies in their ability to be in multiple states at the same time, thanks to a phenomenon called superposition. Imagine that instead of having a switch that can only be on or off, your switch can be in an on-off, and surprisingly, in both states simultaneously. This means that quantum computers can perform massive calculations much faster than traditional computers. Isn't it amazing to think of a device that could solve complex problems in the blink of an eye? The question that arises is, how can quantum computers achieve this? The answer lies in the interconnection of qubits. Through a phenomenon known as quantum entanglement, Qubits can be so deeply connected to each other that the state of one can instantaneously affect the state of another, regardless of the distance separating them. Imagine you have two coins that, when flipped, will always show the same result, either heads or tails, even if they are miles apart. This entanglement is what allows quantum computing to perform multiple calculations simultaneously, potentially leading to revolutionary discoveries. The potential of quantum computing is astounding, but it also raises a series of intriguing questions. What kind of problems could it solve? Many industries are looking to quantum computing as a solution for tasks that are practically impossible for classical computers. For example, cryptography, which is fundamental to the security of our data. Quantum computers could break current encryption systems in a matter of minutes, forcing experts to develop new protection methods. Moreover, simulating molecular systems is another field where quantum computing shines. Imagine being able to simulate the interaction of millions of atoms accurately. This could accelerate the development of new drugs or materials with unique properties. Can you imagine what this could mean for medicine or materials research? However, not everything is that simple. Building a quantum computer is a monumental challenge. Qubits are extremely sensitive to their environment, and any interference can lead to errors in calculations. To overcome this, scientists are developing advanced techniques to keep qubits stable, such as using extremely low temperatures. Did you know that some of these experiments are conducted at temperatures colder than outer space? This demonstrates how delicate and complicated the quantum world is. So when will we see quantum computing in our daily lives? Experts believe we are in the early stages of this technological revolution. Although there are already prototypes of quantum computers, their widespread use could take years or even decades. But research is advancing rapidly, and each small breakthrough brings us closer to an era where quantum computing becomes an integral part of our lives. In the meantime, it is fascinating to consider how quantum computing could change not only technology but also our understanding of the universe. What implications would it have for artificial intelligence or solving complex problems in science? The intersection between quantum computing and other fields could open doors to discoveries we cannot yet imagine. The curiosity for the unknown is what drives scientists to keep exploring, and quantum computing is one of the most exciting frontiers. As we move toward a future where this technology becomes more accessible, it is essential to keep an open mind and be ready to embrace the changes that will come. In conclusion, quantum computing is not just a scientific curiosity, but a promise of a future where the limits of computation expand in ways that could transform our society. From improving the security of our data to revolutionizing medicine, the possibilities are endless. And although we are still at the beginning of this journey, each discovery brings us a little closer to unveiling the secrets of the universe through the lens of quantum computing. With each new advancement, we are reminded that the future is full of surprises and opportunities, and human curiosity is the force that will drive us forward. Quantum cosmology is a fascinating intersection between quantum physics and the science that seeks to understand the universe as a whole. Can quantum mechanics, which describes the behavior of particles on tiny scales, help explain the vast cosmos we inhabit? This question is more than a mere intellectual exercise. It is an attempt to unite two worlds that seem, at first glance, so distant. To begin, let's think about how our understanding of the universe has evolved. In the past, astronomers looked to the sky and formulated theories based on observation. However, over time, it became evident that to understand the secrets of the cosmos, we needed more sophisticated tools. Quantum mechanics presents itself as one of those tools, offering a framework that not only applies to the small, but can also influence the large structures of the universe. How does quantum mechanics relate to cosmology? Imagine you are watching a science fiction movie where the rules of physics seem not to apply. In that world, particles can be in multiple places at the same time, and reality can be influenced by the observation itself. This idea that observation affects reality is fundamental in quantum mechanics and, surprisingly, also has implications for how we understand the universe. The concept that the universe began as a singularity An infinitely dense point raises intriguing questions. What happened in the first moments after the Big Bang? At this point, quantum mechanics plays a crucial role. The theory suggests that, in those initial moments, the laws of physics as we know them fade away. Instead of following the rules of gravity and relativity, the universe behaves according to the strange and often counterintuitive laws of quantum mechanics. One of the most intriguing concepts in quantum cosmology is the idea that the universe could be constantly creating new particles and energy from the quantum vacuum. This vacuum is not empty in the classical sense, but a sea of possibilities. In this ocean of energy, particles appear and disappear in the blink of an eye. Is it possible that our entire universe is the result of this quantum process in the vacuum? When addressing the expansion of the universe, quantum cosmology also offers us new perspectives. The theory of inflation suggests that, in a fraction of a second after the Big Bang, the universe experienced exponential expansion. But what drove it? Some scientists believe that this inflation could be linked to quantum effects, such as fluctuations in the vacuum that gave rise to the energy that propelled this rapid expansion. Let's imagine that the universe is a balloon and that galaxies are points drawn on its surface. As we inflate the balloon, those points move away from each other. This simple image helps us visualize how cosmic inflation may have shaped the structure of the universe. But in quantum cosmology, the way those galaxies are distributed is not just a matter of expansion. It is also influenced by the quantum properties of matter. A fascinating aspect of quantum cosmology is quantum entanglement, the phenomenon where separated particles can be instantaneously connected in some way. This raises questions about the connectivity of the universe. Could it be that galaxies and particles that seem to be separated in space are in fact connected through an invisible quantum fabric? As we explore further, we encounter entropy, a concept that speaks to the disorder and energy of the universe. In the context of quantum cosmology, entropy becomes a key player in the evolution of the universe. How does this idea of disorder relate to the expansion and ultimate fate of the cosmos? The answer may lie in how quantum fluctuations affect the distribution of matter and energy over time. You may wonder, what does all this mean for our place in the cosmos? Quantum cosmology invites us to consider that we are part of a much more complex and beautiful phenomenon than we imagine. Every particle in our body has a story that traces back to the earliest moments of the universe. And that story is intertwined with the mysterious laws of quantum mechanics. As science advances, quantum cosmology also faces challenges. Theories that attempt to unify general relativity and quantum mechanics remain fertile ground for research. Will scientists be able to find a framework that explains both the large and the small? This is the challenge that many modern physicists are trying to solve. In the search for answers, quantum cosmology speaks not only of particles and galaxies, but also of our own existence. It reminds us that in the vast and unpredictable universe, each of us is part of a cosmic dance that unfolds through the laws of nature. The wonder of quantum mechanics and cosmology intertwines to offer a view of the universe that is both intriguing and bewildering. Thus, when reflecting on quantum cosmology, we find ourselves at a crossroads between science and philosophy. It invites us to question not only how the universe works, but also what it means to be a part of it. Each discovery in this field brings us a little closer to unraveling the mysteries of the cosmos, while also reminding us that the adventure of knowledge never ends. In every particle, in every galaxy, in every corner of the universe, there is a story waiting to be told. Are we ready to listen to them? Particle physics is a fascinating journey to the heart of the matter and energy that makes up our universe. In this journey, we encounter the smallest and most fundamental particles, those that, although invisible, are the foundation of everything we see around us. What exactly are these particles and why are they so important? To understand this, let's think of matter as a gigantic building. Each brick, each stone used in its construction, represents a subatomic particle. Without those bricks, there would be no building. And without the particles, there would be no matter that forms stars, planets, and of course, ourselves. Now, what are these particles that make up the fabric of reality? There are three main types: quarks, leptons, and bosons. Quarks are the builders of protons and neutrons, the components of atomic nuclei. Imagine that quarks are like the bricks that form the walls of our building. Without them, protons and neutrons could not exist, and therefore atoms would be impossible. Leptons, on the other hand, include the electron, which dances around the nucleus of atoms like a dancer on a stage. Without electrons, there would be no electricity, light, or chemistry. But what about bosons? These are special particles that act as messengers. Does the photon ring a bell? It is the boson of light and is responsible for transmitting the electromagnetic force. Think of bosons as the mail carriers that deliver messages between particles, allowing everything to function in harmony. Without them, the forces that hold matter together could not operate, and the universe, as we know it, would be total chaos. The history of particle physics is also the history of bold experiments and the quest for knowledge. Since the early days of modern physics, scientists like J.J. Thomson and Ernest Rutherford conducted experiments that challenged our understanding of matter. Through ingenious experiments, they managed to discover these fundamental components. But how are these experiments conducted today? This is where particle accelerators come into play, those enormous machines that seem straight out of a science fiction movie. Imagine a gigantic high-energy circus where particles are hurled at each other at speeds close to that of light. At the Large Hadron Collider, the largest accelerator in the world, collisions occur that create conditions similar to those of the early universe. In those fleeting moments, scientists can observe the creation of new particles and sometimes even discover particles that have never been seen before. Isn't it exciting to think that each collision can open a new window to the universe? The discoveries in the field of particle physics have been astounding. One of the most notable in the last decade was the finding of the Higgs boson, a particle that helps explain how other particles acquire their mass. Before its discovery, the question of why some particles have mass and others do not was a mystery that intrigued scientists. Now, thanks to this discovery, we have a better understanding of how matter forms in the universe. However, this finding is just the tip of the iceberg. Particle physics is not limited to studying what we already know. It also challenges our view of the universe and raises new questions. What is dark matter? Why does it seem that a large part of the universe is made of something we cannot see or detect directly? Particle physics seeks answers to these questions. Ultimately, it is about discovering the true nature of reality. But not everything is straightforward in this field. Theories and models often need to be revised and updated as new discoveries are made. The search for a theory of everything, which would unify all the fundamental forces of nature into a single framework, remains one of the greatest challenges of modern science. Could it be that in the near future we will fully understand the vast and complex universe we inhabit? Particle physics also leads us to consider more abstract concepts, such as the nature of reality itself. Is the matter we see really what it seems? Subatomic particles behave in ways that challenge our common sense. Often they exist in states of probability, being in multiple locations at the same time until they are observed. What does this mean for our understanding of reality and our perception of the world around us? Ultimately, particle physics is a testament to human curiosity and our relentless quest to understand the universe. Each discovery brings us a little closer to the truth, but it also raises new questions that invite us to keep exploring. Just as ancient navigators ventured into the unknown, particle physicists continue their journey to the frontiers of knowledge. With each collision, with each experiment, we are one step closer to unraveling the secrets of the cosmos. And while the road ahead is filled with uncertainties, one thing is for sure: the adventure of particle physics is just beginning. Quantum gravity is one of those topics in physics that seems straight out of a science fiction movie, but in reality, it is one of the most intriguing frontiers of current science. What if I told you that At the very heart of the universe, there is a constant struggle between two of the most fundamental theories of physics, quantum mechanics and general relativity. These theories have been, until now, like two giants that fail to find common ground. But could we finally unite them and better understand the universe? To begin with, let's consider what makes each of these theories so powerful. Quantum mechanics describes the behavior of subatomic particles, those tiny units that make up everything we see around us. Imagine a world where things are not as predictable as they seem. In this quantum world, particles can be in multiple places at the same time, or they can behave like waves. It is a place where uncertainty reigns and where the rules that govern our day-to-day lives do not apply. On the other hand, general relativity, formulated by Einstein, helps us understand how gravity affects massive objects like planets and stars, describing how space-time curves around them. But what happens when we try to combine these two visions of the universe? Quantum gravity seeks precisely that, to find a way to unite quantum mechanics and general relativity into a single coherent theory. Imagine you are trying to fit together two pieces of a puzzle that seem to have nothing in common. That is how many physicists feel when trying to create a theory that explains how gravity works at very small scales, like those found inside a black hole. In these extreme places, the laws of physics seem to break down. And scientists wonder, what happens to information when something is swallowed by a black hole? One of the most promising theories attempting to solve this mystery is string theory. This idea suggests that particles are not points, as previously thought, but rather tiny vibrating strings. Each type of particle corresponds to a different vibration of these strings. But how does this fit with gravity? By considering gravity as a manifestation of the vibration of these strings, scientists hope to describe both gravity and the other fundamental forces of nature within a single theoretical framework. But is this really possible? Some physicists have also been exploring the idea of loop quantum gravity. This theory proposes that space and time are not continuous but are made up of small discrete units. Imagine a network of bricks where each brick is a small part of space-time. This could help avoid the paradoxes that arise when we try to apply quantum mechanics to gravity. But it also raises new questions. What does time really mean in this context? The search for a theory of quantum gravity is not just an academic exercise, it has profound implications for our understanding of the universe. If we manage to unify these theories, we could answer fundamental questions such as, how did the universe begin? What happened in the first instant after the Big Bang? And most intriguingly, what occurs inside a black hole? These are questions that still elude us, but could be revealed if we manage to understand how gravity and quantum mechanics interact. As we delve into this fascinating quest, new ideas and discoveries emerge. For example, some scientists are exploring the role of entropy in quantum gravity. Entropy, which measures disorder in a system, could be related to how gravity acts at the quantum level. This leads us to wonder, could the disorder in the universe have a purpose in how we understand gravity? There are those who believe that the key to unraveling quantum gravity may lie in future experiments. With the advent of new technologies and particle accelerators, such as the Large Hadron Collider, we could obtain evidence that helps us confirm or refute these theories. But are we ready for the challenges this entails? Science advances by leaps and bounds, and each discovery raises more questions than answers. In this journey towards understanding quantum gravity, we also reflect on our own existence. If the universe is a place where gravity and quantum mechanics intertwine, what does this mean for us as human beings? Are we connected in some way to these fundamental forces? Science and philosophy often clash, but in this case they may be more intertwined than we think. The search for a theory of quantum gravity is not only a scientific challenge, but also a fascinating journey into the unknown. Every step we take brings us closer to a better understanding of the nature of the universe and our place within it. As we explore these ideas, let us remember that human curiosity is what drives us to keep seeking answers, even when those answers seem beyond our reach. Finally, as we look to the future, The question that remains is, will we be able to unravel the mysteries of quantum gravity as science progresses and new theories develop? We can be sure that our understanding of the universe will continue to evolve. The adventure is just beginning, and each discovery brings us a little closer to the truth. What if I told you that the universe has a destiny, an end that could be as impressive as its beginning? In this section, we will explore the theories that attempt to unveil the future of the cosmos. From the vast expansion that characterizes it to the possibility of a total collapse, the fate of the universe is one of the great mysteries of modern science. To begin, it is essential to understand that the universe, as we know it, is in constant motion. It is expanding, and this expansion not only continues, but according to the latest observations, is accelerating. What does this mean? Imagine you are inflating a balloon. At first, the air enters in a controlled manner, but as you keep blowing, the rate of expansion increases. This is similar to what happens with the universe. But how far does this expansion go? The first theory we will consider is the Big Freeze, an idea that suggests the universe will continue to expand indefinitely. In this scenario, galaxies will drift apart and stars will eventually burn out. The light from the stars we see today is an echo of the past. As the universe cools and expands, stars will shine less, and the cosmos will become a cold, dark place. Can you imagine a universe where everything we know has faded away? On the other hand, there is the Big Crunch, a theory that suggests the expansion of the universe could someday reverse. In this scenario, after trillions of years, gravity could win the battle and pull everything back to a singular point. The universe would shrink, collapsing into an extremely dense and hot state, similar to the state it was in before the Big Bang. What would happen at that moment? A catastrophic ending worthy of a science fiction movie where everything returns to a point, perhaps just to begin again. Another intriguing possibility is the Big Rip. In this hypothesis, dark energy, which currently drives the acceleration of expansion, would become so powerful that it would tear everything apart. Galaxies, stars, and even atoms could be disintegrated, leading the universe to a chaotic end. Can you imagine witnessing such a phenomenon where the very structure of the cosmos disintegrates before our eyes? As we explore these theories, it is fascinating to consider the timescale involved. We are talking about trillions of years, a time that exceeds our capacity for comprehension. To put it in perspective, if the history of the universe were a day, we would have only been here for the last second. How does it feel to be a spark in the vastness of eternity? Throughout our existence, humanity has sought answers about our place in the cosmos. Each theory about the future of the universe invites us to reflect on our own existence. If the universe cools and darkens, what will remain of us? Will we be just a memory in a vast void? The implications of these theories also lead us to question the nature of time itself. If time is a dimension that expands and contracts, does this mean that the future is predetermined or that it is a blank canvas? Can we in some way influence the fate of the universe? As science advances, so do our questions. Quantum physics, cosmology, and philosophy intertwine in an attempt to understand what lies ahead. The theories we discuss are just a glimpse of what science has achieved so far. But the real challenge lies in understanding what we do not know. The fate of the universe is not just a matter of science, but also of philosophy and spirituality. What does it mean for us, as individuals and as a species, to know that we are on a journey toward an uncertain destiny? It invites us to appreciate every moment, every shining star in the darkness. In this vast universe, every life has a unique value, a brightness that, although fleeting, leaves a mark. The theories about the future of the universe also reflect our own struggle to understand existence and meaning. Ultimately, by exploring these possibilities, we are not only inquiring into the fate of the cosmos, but also into the meaning of our own lives. So, as we contemplate the future of the universe, let us remember that, although the end may be uncertain, each of us has the power to make this moment count. The universe may be vast and mysterious, but it is also a reminder that we are here now, in this moment. and that in itself is an extraordinary quantum phenomenon. In the end, the questions that arise about the future of the universe are a reflection of our search for answers. What legacy will we leave? How will we be remembered in this cosmos? Every day, every choice we make contributes to the story that is being written. The adventure of the universe continues, and we are part of it. Quantum physics has opened up a world of possibilities that at first glance seem to challenge our understanding of reality. What do these discoveries really mean for us? One of the most fascinating questions that arises is, what philosophical implications do quantum findings have for our existence and the universe we inhabit? Reality may not be as objective as we think. At the quantum level, observation seems to play a crucial role. Is it possible that our perception influences the very nature of reality? The idea that the observer affects the observed may seem strange, but in the quantum world, this is a reality. Think of a subatomic particle that can be in multiple places at the same time until someone measures it. By measuring it, the particle chooses a location. This notion leads us to question the role we play in the universe. If our consciousness can influence the behavior of particles, are we in some way co-creators of our reality? In this context, the question of whether there is a purpose behind existence also arises. If the universe is a vast field of possibilities, does that mean that every choice we make can alter its course? This invites us to reflect on the nature of free will. Are we really making decisions, or are we simply following a path already laid out by the laws of physics? The duality between determinism and free will is a dilemma that has intrigued philosophers for centuries. Moreover, the idea that the universe is interconnected at a quantum level suggests that everything we do has an impact, not only on our lives but on the entirety of the cosmos. What does this mean for our relationships, our daily decisions, and our responsibility towards others? If every action has repercussions on the fabric of the universe, we may be compelled to reconsider how we live and how we treat one another. In this sense, quantum entanglement offers another layer of complexity. Two particles can be connected in such a way that what happens to one instantaneously affects the other, regardless of the distance separating them. What implications does this have for our understanding of human connection? The idea that we are all interconnected at a fundamental level could inspire us to be more compassionate and to work towards greater unity in our communities. Quantum mechanics also challenges our notion of time. In the subatomic world, time seems to lose its linearity. What if the past, present, and future were, in some way, interdependent? Could this open the door to the idea that all moments coexist, and that our perception of time is simply an illusion? This perspective could radically change how we live our lives, fostering a greater appreciation for the here and now. The implications of quantum physics are not limited to philosophy. They also lead us to question our own nature. If consciousness can influence the behavior of particles, what does this mean for our understanding of the mind and the human being? The relationship between science and consciousness is an expanding field of study, where neuroscience intertwines with quantum physics. Could we one day understand how our consciousness works through quantum principles? However, we cannot ignore the ethical questions that arise from these discoveries. If our decisions can influence the universe, what responsibility do we have towards our actions? This leads us to reflect on how we interact with the world and with others. Quantum physics invites us to be more aware of our choices, to live more intentionally, and to consider the impact we have on the environment around us. Quantum philosophy also encourages us to question the nature of knowledge. Is absolute knowledge possible? Or is it limited by our perception? If reality is a construct influenced by our observations, how can we aspire to understand it in its entirety? This dilemma leads us to consider intellectual humility and to accept that perhaps we will never come to know all the answers. Finally, the exploration of these philosophical ideas leads us to question the meaning of our existence. If the universe is a vast field of possibilities, what is our role in it? Are we here to learn, experience, and grow, or is there a greater purpose that we have yet to comprehend? These questions, although difficult, are essential to our journey as human beings in such a complex and fascinating world. Quantum physics has become a gateway to a new understanding of reality. It pushes us to reflect on our lives, our consciousness, and our place in the cosmos. The deeper we delve into these questions, the richer our encounters with life itself become. Thus, the journey becomes not only an intellectual exercise, but also a spiritual exploration that invites us to be more aware of our connection with the universe and with each other. The connection between quantum physics and consciousness is a topic that has fascinated scientists, philosophers, and curious minds alike. What if I told you that the way we understand the universe might be related to how we think and feel? At this point, the question arises, is consciousness simply a product of our brain, or is there something deeper at play? This question has led to passionate debates and intriguing theories worth exploring. Consciousness, in simple terms, is our ability to be aware of ourselves and the world around us. But how does this relate to quantum physics? Some scientists suggest that consciousness could arise from quantum processes in the brain. Imagine that instead of being just a set of neurons firing electrical impulses, your brain acts like a small quantum universe where subatomic particles interact in ways that could influence our thoughts and decisions. This suggests that consciousness could be more than a biological phenomenon. It could be a manifestation of the quantum laws that govern everything in the universe. Now, what does this mean for our understanding of reality? If consciousness is connected to quantum mechanics, then our perception of the world could be more flexible than we think. In quantum mechanics, particles can exist in multiple states at the same time, a phenomenon known as superposition. This leads us to wonder, could our mind also be in a state of superposition, where multiple possibilities coexist until we make a decision? This concept is fascinating, as it could imply that our choices are not as linear as they seem. Let's consider another intriguing aspect, quantum entanglement. This phenomenon occurs when two particles are so interconnected that the state of one instantaneously affects the state of the other, regardless of the distance separating them. What if our consciousness were also entangled in some way? Could we be connected to other people on a deeper level? These questions open up a range of possibilities about how we interact with the world and with each other. Speaking of interactions, it's interesting to note how our emotions can influence our perception of reality. Quantum physics tells us that the observer affects the outcome of an experiment. This raises an intriguing question. Could our consciousness influence the reality we experience? If our mind has the power to alter the state of things at a quantum level, then our intentions and emotions could have a greater impact on our lives than we imagine. But not everything is that simple. Science is a path filled with uncertainties, and while there are fascinating theories, there is also skepticism. Some physicists argue that consciousness and quantum mechanics are two areas that should not intertwine. For them, consciousness is a complex phenomenon that can be explained through neuroscience without resorting to quantum physics. This leads us to question, to what extent do we need to understand the nature of consciousness to address questions about our existence? Another interesting perspective comes from philosophy. Some thinkers have suggested that consciousness could be a fundamental component of the universe, similar to how matter and energy are essential. From this viewpoint, consciousness is not just a product of the brain, but an integral part of the fabric of reality. This invites us to reflect, is it possible that consciousness is as fundamental as space and time? As we explore these ideas, it's important to consider the ethical implications that arise. If our consciousness is connected at a quantum level, what does this mean for our responsibility towards others and the world? The decisions we make could have broader repercussions than we think, prompting us to adopt a greater awareness of our actions and their impact on the universe. The quest for answers about the connection between consciousness and quantum physics has also led to the development of new technologies such as quantum computing. As we advance in our understanding of quantum principles, we may discover innovative ways to interact with information and consequently with our own minds. This raises an intriguing question. Could quantum technology help us better understand our own consciousness? Finally, it is crucial to remember that although these theories are fascinating, we are still in the early stages of exploring the relationship between quantum physics and consciousness. Each discovery opens new questions and possibilities, and the road ahead is filled with mysteries to unravel. Are we prepared to face these challenges and expand our understanding of what it means to be conscious? As we reflect on the relationship between consciousness and quantum physics, it is evident that this topic is not just a matter of science, but also an invitation to delve deeper into the nature of our existence. In the end, the quest for answers about our consciousness could be, in itself, one of the most exciting explorations humanity has ever undertaken. The universe, a vast stage of wonders and mysteries, often leaves us with more questions than answers. What does our place in this immensity really mean? Is everything interconnected in some way? Reflecting on the concept of quantum winter, we find ourselves at the crossroads of science and philosophy. This term not only evokes images of a cosmic cold, but also invites us to explore the depths of reality itself. When we speak of quantum winter, we refer to a state in which subatomic interactions seem to slow down, as if the universe is taking a breath. But what implications does this have for us? In a sense, it could be a reminder that, in the dance of the cosmos, there is always a balance between chaos and order. Every particle, every star, every galaxy plays a role in this universal symphony. Quantum mechanics, with its strange properties, becomes the score that sets the rhythm. When considering the future of the universe, we cannot ignore the theories about its ultimate fate. Are we destined for a big freeze where everything cools and disperses, or a big crunch where everything collapses into a point? These theories, although they often sound like science fiction, are the result of deep scientific analysis. But how do these ideas affect our understanding of life and existence? They teach us that although our lives may seem ephemeral, we are part of a much larger and more complex process. Entropy, that concept often misunderstood, plays a crucial role in all of this. It tells us that disorder tends to increase over time in the context of the universe. This may seem daunting, but could we see it as an invitation to find beauty in impermanence? Each moment is precious precisely because it is transient. Life, like the universe, is in constant change. Delving into the paradox of information, we find a thread that connects quantum physics with our consciousness. Can information truly be destroyed, or does it simply transform? This question is not only relevant to physicists, but also has profound philosophical implications. If information is never lost, does this mean that our experiences and memories are eternal in some way? This knot of connections between science and philosophy invites us to reflect on the very nature of our reality. The idea of parallel universes, which often seems straight out of a science fiction novel, makes us question the uniqueness of our existence. What if there are other versions of us in other universes, making different decisions and living alternative lives? This thought pushes us to reconsider our choices and their impact. In a sense, every decision we make can open a path in an infinite maze of possibilities. String theory, with its promise of unifying the fundamental forces of the universe, reminds us that everything is connected. Imagine the forces as vibrating strings resonating in a delicate balance. This balance applies not only to the laws of physics, but also extends to our daily lives. Every action has a reaction, every choice resonates in the fabric of reality. By recognizing this, we become more aware of our decisions and their impact on the world around us. Quantum computing, although it seems a futuristic concept, has the potential to transform our understanding of the universe. By utilizing principles of quantum mechanics, it promises to solve complex problems that seem insurmountable today. But how does this translate into our daily lives? Perhaps it will allow us to unravel mysteries that have eluded humanity for centuries, from healing diseases to creating sustainable energy. As we explore quantum cosmology, we realize that quantum mechanics applies not only to the small, but also has implications for the cosmos as a whole. It invites us to see the universe not as a cold and distant place, but as a vibrant environment full of possibilities. Every star, every galaxy is a reminder that the unknown is always around us, waiting to be discovered. Quantum gravity, in its attempt to unite quantum mechanics with gravity, leaves us with more questions than answers. Is it possible that in the depths of space and time there is a connection that we still do not understand? This yearning to comprehend the ineffable is part of our human essence. It drives us to keep searching, to keep questioning, and ultimately to keep dreaming. And in the end, when we reflect on the philosophical implications of these discoveries, we realize that science and consciousness are not separate. Quantum physics invites us to reconsider our relationship with the universe and with ourselves. Every discovery not only expands our knowledge, but also brings us closer to a deeper understanding of our existence. In this journey through quantum winter, we have touched on issues that go beyond the physical. We have delved into the heart of reality, where science and philosophy intertwine. As we conclude this journey, we remember that we are in a constant process of exploration. The universe is an evolving mystery, and we, as its observers and participants, have the opportunity to marvel at its greatness. So the next time you look up at the starry sky, ask yourself, what secrets does the universe hold? What role do you play in this vast cosmic narrative? The search for answers continues, and every question is a spark that can ignite new ideas and discoveries. In this quantum winter, each of us is an essential part of the cosmic story.